Hello everyone. This video would focus on multiplying radicals, and this is the third part. In this part, we're going to use the area model to multiply radical expressions. Before we go further, please feel free to check out the description box below for the link of the other series of topics related to radical expressions. Before we jump into this example right here, let's have a review on the parts and the definition of radical expressions. Please remember that these are the parts of every radical expression. The first part is the radical symbol. The reason why this is called radical expression is because it is an expression that contains the radical symbol. Our A here is called a coefficient. A coefficient is a number multiplied to the radical expression. And the letter N here is called the index. This tells you which root you're looking for. Please remember that if the value of the index is not written in there, it means that that invisible number is 2. We also have a letter C, and this letter C is named as the radicand. A radicand is the value that you are taking the root of. So this expression that we have here is read as A times the nth root of C. So this is read as square root of 36. So if we wanted to know what is the value of square root of 36, we can go ahead and equal this whole expression to x. So this is read as square root of 36 equals x. Now we are going to rewrite this into its equivalent exponential form. This expression or this equation that we have here means that x squared is equal to 36. What is x? So if you notice, our x here becomes the base of the exponential form, while our index of 2, which is invisible, becomes the exponent in the exponential form, and our radicand, which is 36, will become the answer to the exponential expression. What we're trying to do right now is we're supposed to determine the value of x such that when we multiply this x by itself twice, it will give us 36. Meaning if we have blank times blank equals 36, and it should be the same number. So then these two numbers would be 6 times 6. So 6 times 6 is 36. And so we can go ahead and rewrite this as 6 squared equals 36. And so this tells us that our x is 6. So then this square root of 36 then will equal to 6. So that's how we evaluate radical expression. So these are the parts and definition of radical expressions. Okay, so let's go back to the example here. So we are given these two terms in this first expression. They are placed inside the parentheses. And we also have two terms inside this second expression. So what are we going to do is that we are going to create the area model. So the dimension of the area model that we're going to create would be a 2 by 2 box. So I'm going to go ahead and write that 2 by 2 box on the side here. Okay, the one that we write into the box here would be these terms. So we're going to start with 3. So I'm going to put 3 here. And then that's a negative 2 square root of 3. And then on the other one right here, we have 1. And then we got a negative 3 square root of 3. So what are we going to do is we are going to multiply each of them. So we're going to have 3 times 1 is 3. And then we also have 3 times negative 3 is negative 9. And then we copy the square root of 3. And then we also have negative 2 times 1 is negative 2. And then we copy the square root of 3. And then we have negative 2 times negative 3 is a positive 6. And then we have a square root of 3 times 3 is 9. So we're going to simplify that as we write it out here. So what we would do is we are going to write them all out. So we start with 3. So I'm going to put that in here. So 3. And then we just copy all of these. So that would be minus 9 square root of 3. This is for this. And then we have a minus 2 square root of 3. And then we have a plus 6 square root of 9. So in this problem right here, we can tell that these two are like radicals because their indices are the same. That's invisible 2. And their radicands are the same, which is 3. So we can go ahead and combine these two like radicals together. And then as you can see here, this square root of 9 can be simplified to 3 so that we can go ahead and rewrite this as 3. Then we combine these two together. Since they are like radicals, we are adding their coefficient. So that's going to be negative 9 minus 2. That comes out negative 11 square root of 3. We just copy the common radicals for both of them. And then we're going to have a plus 6 square root of 9 is 3. So we can simplify this to be 3 minus 11 square root of 3 plus 18. And then we combine like terms further. The like terms that we have right now are the constants. So we have a 3 plus 18 is gonna be 21. And then we just copy this minus 11 square root of 3. So this is the product of these two radical expressions that we have up there. Now notice that we can't simplify this further because they are unlike radicals. The other one has a square root of 3, the other one is a whole number. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So in this case right here, we have two terms inside the first parentheses, and we also have two terms inside the second parentheses. So we can go ahead and say that the dimension of the area or the table that we're going to create would be a 2 by 2 box. So I'm going to go ahead and draw that 2 by 2 box on the side right here. So what I would do next is to multiply each of the terms here so that we can fill this table in. So I'm going to go ahead and show the work down here. So what I would do next is to write this all out in here. So I'm going to show the work down here. Okay, so what I did here was I wrote them all out in here, and we are going to combine like terms. So the like terms that we have here are these two, because again, we have an index of 2 and we have a radicand of 5. So we go ahead and combine these two together. So these are like terms. And then we can also simplify this square root of 25 and square root of 49 so that we can go ahead and say that these two are opposite to each other. So when we're going to add them, they're going to cancel out. So it turns out 0. So the leftover would be this 2 here. So this would come out 9. The square root of 25 is 5. And then we have a minus 4. The square root of 49 is 7. So again, we actually canceled these two out because they positive 6 minus 6 is a 0. So it turns out 0, so it's gone. And so we can go ahead and simplify this to be 9 times 5 is 45. And then minus 4 times 7 is 28. And so the final answer when we subtract 28 from 45 is 17. So this is the simplified version, or this is the product of these two radical expressions. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!